So when we talk about collecting observations in science, we've discussed previously that science is based on observations. We collect data by taking measurements using tools called instruments. An example of an instrument would be a ruler, for example. Now, when we take a measurement in science, each measurement has a number and a unit. For example, 10 meters. 10 is our number, meters is our unit. Now, when we start to talk about handling numbers in science, and especially in chemistry, where we're describing often very small particles or very large collections of particles, we often deal with very large or very small numbers. As a result, we have to use what's known as scientific notation, also known as base 10 notation. So scientific notation has a general form of blank times 10 to the n. So this blank is your number. This number must be greater than or equal to 1. And less than 10. So for example, 1.05, that's more than okay. 9.56, that's more than okay. Both of these numbers are greater than or equal to 1 and less than 10. 0.95 doesn't meet the criteria. 0.95 is less than 1. Likewise, you can't put 10.0 because 10 is not less than 10. So whatever number you put in the number section for scientific notation must be greater than or equal to 1 and less than 10. Now, this 10 to the n, 10 is our base and n is our exponent. N can be any whole number power, so no decimals. And n can be negative or positive to describe small numbers and very large numbers respectively. So for example, 10 to the second, more than okay. We have a whole number power. 10 to the negative fifth, that's also more than okay. Whole number power, but we can have negative numbers, that's more than okay. Let's go over some examples of things that are not okay for your exponent. 10 to the 0.5 is not okay because we must have a whole number power, no decimals for this exponent. Likewise, 10 to the 2.6 is not okay because again, it's not a whole number. So putting this together, when we write out a number in scientific notation, the number must be the number that you're putting before your base 10 must be a number greater than or equal to 1 and less than 10. Your exponent, which is what you're raising your base 10 to a given power, must be a whole number. 2, -5, those are more than okay. 0.5, 2.6 aren't whole numbers, so they are not applicable. So here are some examples of numbers that are correctly written in scientific notation. So if we wrote 0.0567 in scientific notation, it would be correctly written as 5.67 times 10 to the negative second. As you notice, this number is greater than or equal to 1 and less than 10. And our exponent, which is our power of 10, is a whole number. Likewise, if we had something like 113, we write this as 1.13 times 1.135 times 10 to the second is greater than or equal to 1 and less than 10, and 10 to the second whole number. To show some examples of numbers incorrectly written in scientific notation, if we had 0.0 incorrect to write this as 0.935 times 10 to the negative first. The main problem is that 0.0935 is less than 1. So this number is not okay for scientific notation. In order to write a number in scientific notation, the number that you write out that's being multiplied greater happens, but I'm going to bring 8 and to try to numbers in terms of fractional power. But for example, if you wrote a number out in the form 1.5 times 10 to the 0.6, that would not be okay. You should never have a decimal for your power of 10. You must always have a whole number. It can be positive or negative, but it must be a whole number. Now, so we've talked about the rules for writing numbers into scientific notation. Let's talk about how we translate a decimal into a number in scientific notation. But before we do that, it's important that we understand how exponents function. So an exponent has two parts, a base and an exponent. The way that you read these exponents is that you multiply the base by itself a total of n times, where n is your exponent. So for example, 10 to the second, we'd multiply 10 times 10. We'd multiply 10 by itself a total of 2 times. Now, one easy way to convert powers of 10 into a fully written out number is to use a decimal point trick. So for powers of 10, you move the decimal point n spaces to the right if n is positive. So if you have a positive exponent for your power of 10, so we write 10 to the 7th as 1.0 times 10 to the 7th. Okay, there's always an implied 1 here. We've now written out our decimal point. So we're going to take that decimal point and we're going to move it n spaces to the right. 1, 2, 3, and I always like to put a placeholder 0 every time I move. 1, 2, placeholder 0, 3, placeholder 0, 4, placeholder 0, 5, placeholder 0, 6, placeholder 0, 7, placeholder 0. So that gives us 1, 1, 2, 3. Oops, I put my dividing line 1, 2, 3, 4, 5, 6, 7, 7 zeros. 1, 2, 3, 4, 5, 6, 7. So this would be 10 million. And you can even put the decimal point at the end if you want to make sure you've kept track of everything properly. So as you've seen, we can convert positive powers of 10 into fully written out numbers via moving the decimal point n spaces to the right if your exponent n is positive. Since we had 10 to the 7th, and this is positive 7th, we move our decimal point over 7 spaces to the right. So this is very useful because when you're dealing with unit conversions and when you're dealing with scientific notation and you want to take your number written in scientific notation and expand it out into a decimal, you're going to have to multiply by different powers of 10 invariably. Let's now talk about negative exponents. So 10 to the negative n, so if we have a negative exponent, is the same as 1 over 10 to the n. So for example, 10 to the negative third can be thought of as 1 over 10 to the third. And we can write this out as 1 over, so 10 to the third. We put our decimal point down and we move it 3 spaces to the right. 1, 2, 3. That gives us 1,000. So 1 over 1,000, if you punch that into your calculator, will be 0.001. So that's one way to write out negative exponents. The other way that also utilizes a decimal point shortcut is that for powers of 10, if you're multiplying by negative powers of 10, you move your decimal point n spaces to the left if n is negative. So for example, 10 to the negative fifth, we can rewrite as 1 times 10 to the negative fifth. And now that we have this set up, following our shortcut rule, we're going to, since we have 10 to the negative fifth as our exponent, we're going to move our decimal point 5 spaces to the left. So 1, 2, make sure to put a placeholder 0. 3, another placeholder 0. 4, another placeholder 0. And 5, another placeholder 0. So that in turn gives us 0.00001 as our fully written out exponent. Okay, so we've talked about how to multiply by positive and negative powers of 10. So let's put this together with the rules for scientific notation to talk about how to write out numbers in scientific notation. So let's do an example. And let's start with the number 543.7. Okay, a generic common number that you may measure if you're measuring the volume of an object, for example. So we've written out our number, and let's go through a step-by-step guide to write this number in scientific notation. First, we write the number, and we place a decimal point at the end if there is no decimal point. Okay, so we've written out our number. From here, what we're going to do is we're going to move the decimal point into the number blank is greater than or equal to 1 and less than 10. So if we have 543.7, I move my decimal point. If I want this to be a number between 1 and 10, I'm going to need to move my decimal point to the left. So I move it over 1 space. I have 54.37. That is still greater than 10. So I'm going to move my decimal point over 1 more, and I get 5.437. So as we can see, this number is greater than or equal to 1 and less than 10. Okay. Now, we've moved our decimal point to get a number between 1 and 10. So in this process, 543.7, we moved our decimal point over 2 times to give us 5.437. So we're next going to count how many places the decimal point was moved and if it was moved to the left or right. So as we can see in this example, when we have 543.7, we moved our decimal point 2 spaces to the left. Thus, when we're writing out our exponent in scientific notation, n is equal to the number of spaces moved to the left. N is generally positive if your starting number is greater than 1. So 543, definitely greater than 1. We had to move our decimal point 2 spaces to the left, so that would give us 10 to the second. So putting this together, that gives us 543.7 turns into 5.437 times 10 to the second. Now, let's look at another example. Suppose I have 1,030. So just to refresh this, we put a decimal point at the end if the number doesn't have a decimal point. We then move our decimal point until we end up with a number between 1 and 10. Moving our decimal point over 3 times gives us 1.030. And because we moved our decimal point 3 spaces to the left, that would give us a positive power of 10. So that would give us 10 to the third. Let's look at an example where we have a negative exponent. And we'll do 2 of those. Suppose we have the number 0.00567. And if we wanted to convert this into scientific notation, our first order of business is to get a number between 1 and 10. So to do that, we're going to move our decimal point to the right. 1, 2. So if we move it over 2, we'd have 0.567. That's not good enough quite yet, so we need to move our decimal point to the right one more time to give us 5.67. So in this process, to get a number between 1 and 10, we've moved our decimal point over 1, 2, 3 spaces. So we've moved our decimal point over 3 spaces to the right. Okay, so we have 5.67, and following our guide, n is equal to -1 times the number of spaces moved to the right. So since we moved our decimal point over 3 spaces to the right, it would be 10 to the -3rd. N is negative if your starting number is less than 1. So we'd write 0.00567 as 5.67 times 10 to the -3rd. Let's do another example, 0.0135. So first, we have to move our decimal point over to give a number between 1 and 10. So we'd move our decimal point over 2 spaces, and that would give us 1.35. Now, since we moved our decimal point 2 spaces to the right, we'd write our power of 10 as 10 to the -2nd. Very large numbers have positive powers of 10 when written in scientific notation. Very small numbers have negative powers of 10 when written in scientific notation. So we've talked about the rules for multiplying by positive and negative powers of 10. We've also talked about the methods to take numbers and write them in scientific notation and the rules to properly write numbers in scientific notation. One thing I want to show everyone is a method to check our work. So if we started, for example, with 1030 and we wrote it as 1.030 times 10 to the third. If we want to check our work here, this is just our little comprehension check. What we can do is we can multiply out this number written in scientific notation and convert it back to our starting number. So we know that when we multiply by positive powers of 10, we move our decimal point to the right 3 spaces, 1, 2, 3. So multiplying out this number written in scientific notation, we get 1030. So we've in effect checked our work. We can do the same for this 5.437 times 10 to the second. In this case, when we're multiplying by a positive power of 10, we move our decimal point 2 spaces to the right, and that gives us 543.7. So we've in effect checked our work. We can also do this to check our work for the negative exponents. So if we have 5.67 times 10 to the negative third, this time we're multiplying by a negative exponent. So we move our decimal point 1, 2, 3 spaces to the left, and that gives us 0.00567. So we've checked our work. So as you can see, we can take any number and write it in scientific notation and then double check that we've converted the number correctly into scientific notation using our rules for multiplying by positive and negative powers of 10. So let's tie this all together, and I'm going to be doing the following example. So I'm going to do the first two, and then you're going to work on the second two and answer those questions on the provided prompt. So in this case, we're asked to convert the following numbers to scientific notation. So 4,534. So following my procedure, the first thing I'm going to do is I'm going to put a decimal point at the end of my number. Now I need to convert this number into a value between 1 and 10. So I'm going to move my decimal point over 1, 2, 3 times. That gives us 4.534. And now following our rules, we moved our decimal point 3 spaces to the left. So when we convert numbers into scientific notation using this method, because we moved our decimal point 3 spaces to the left, and because we started with a number that's clearly greater than 1, we're going to have a positive power of 10. And since we moved 3 spaces to the left, it would be 10 to the positive third. Now we can check our work here. So if we take 4.534 times 10 to the third, and we multiply out this number, we'd multiply by a positive power of 10. And when we multiply by positive powers of 10, we move our decimal point to the right, equal to the exponent. So we'd move our decimal point to the right 3 times, and that gives us 4,534. So we have checked our work for this problem. Let's do another example as part of our guided practice. So we have 0.0034201. So this number is clearly less than 1. So we're definitely going to have a negative power of 10 when written out in scientific notation. So we're going to move our decimal point until we have a number between 1 and 10. So moving our decimal point 3 times gives us 3.4201. And we moved our decimal point 3 spaces to the right. And when you convert numbers into scientific notation using this method, your power of 10 is negative times the number of spaces moved to the right. So in this case, we moved our decimal point 3 spaces to the right. So we'd have an exponent of 10 to the negative third. To check our work on this, if we rewrite our number and we multiply out this exponent, if we're multiplying by a negative power of 10, we move our exponent to the left. In this case, we move it to the left 3 times because we're multiplying by 10 to the negative third. And that in turn gives us 0.0034201. So we have fully checked our work for this problem. So now what we're going to do is we're going to have you work on the following 2 examples. And you're going to submit your responses on the assigned Canvas quiz module. So this is another one of our in-class problem-solving activities, and you'll see a problem set below this video. So I'll give you a few moments to work on this problem and submit your responses, and we'll go over the solution after your responses are submitted.